Hello, welcome to a parts and totals proportion example. Let's take a moment to read the word problem. An industrial cleaner is diluted 4 parts of water to 1 part of cleaner. What volume in milliliters of cleaner should be used to get a total of 480 milliliters of diluted solution? How many milliliters of water are needed? There are 2 questions in this problem. The one is the milliliters of cleaner, the other is the milliliters of water. When I look at the first sentence, I see that we should use 4 parts of water and 1 part of cleaner. When I think about making a proportion, I know that a proportion is 2 equal fractions. And so I am initially thinking of an idea that I should put 4 parts water over 1 part cleaner from that first sentence, because this gives the information in that first sentence as a fraction. And then the idea of a proportion is to put an equal sign and to put similar concepts in the corresponding locations. The challenge that I run into here is that in the next sentence, I am given a total that I'm circling here on my screen. So because it is a total, it can't go on the top because the top of my fraction represents water. And because it is a total, it can't go on the bottom because the bottom of my fraction represents cleaner. And so I'm given a number, 480 milliliters total, and it doesn't match anywhere. I'm also not told the amount of water, and I'm not told the amount of cleaner, so I don't have any matching concepts to make 2 equal fractions. So I'm crossing out this initial thought because it doesn't work. So what I'm going to do instead is draw a bar model. And the bar model is similar to the image that I have down below here. And a bar model is used to create the parts and total and see how they work together. So you see the dilution is modeled here with the flasks. So there are 4 flasks of water, 1 flask of the cleaner, making the all-purpose mixture. A bar model is a much simpler drawing. So because it told me that I need 4 parts of water, I'm drawing 4 approximately equal squares to create a bar. I'm labeling all of them water because it's 4 parts of water. And then it told me 1 part of cleaner, labeling that C for cleaner. So 4 water, like the 4 flasks, 4 squares. 1 part of the cleaner, 1 flask, 1 square. So in my model, I see that there are a total of 5 parts. Now, that's really, really helpful because there's a total. And up here circled in the problem, I have a total. So those are matching concepts. They're the total with different labels, but they're the total. And knowing that is going to allow me to create equal fractions. So the first question that I'm asked is what volume of cleaner? So because I'm asked about the cleaner, I'm going to put in my fraction the 1 part cleaner. And instead of including the 4 parts of water, instead I'm going to include the 5 total parts. And then going with the idea of creating a proportion, I put my equal sign. I put my other fraction bar because proportions are equal fractions. And now I have a concept that's a corresponding concept. I know that there are 480 milliliters total. And so I'm putting that on the bottom of my fraction because that's where the other total is in my first fraction. And to have equal fractions, I have to have equal concepts. And then on the top of this fraction, I'm going to put the X, and I'm going to put the milliliters of the cleaner. And again, the reason why I can do this is because it's a similar concept to having the 1 part of the cleaner. Since I've set up a true proportion, two equal fractions, comparing two equal concepts in the same manner, I'm able to solve using the cross product. Cross product is where we multiply diagonally, and so multiplying the 1 times the 480, I get 480. Multiplying on the other diagonal, I get equals 5x. Then I can solve this equation by dividing by 5 on each side. And I get x is equal to 96 milliliters of the cleaner. Now, there is a second question, and the second question can be solved by a variety of methods. And so this 96 milliliters is one part. I see that there are 4 parts of water. All the parts are equal. As you can see, all the flasks of water in the image and the flask of cleaner are equally full. So one option to solve for the amount of water would be to take 96, the amount in one part, times 4, because there are 4 parts of water. And so if I take 96 times 4, I get the answer of 384 milliliters of water. Excellent way to solve, but there are other ways. So you might have been thinking of something different. Another way to solve that's very straightforward is to take the total, 480, subtract out the amount of cleaner, the 96 that we found, and by doing that subtraction, I also get 384 milliliters of water, because I know that there are just 2 substances mixed together in the diluted solution. The final method is the more mathematically complex method, but it would be to use a proportion similar to what we did to find the cleaner. So I would use 4 parts of water out of 5 total. And that would equal X milliliters of water out of 480 total. I would then solve this with the cross product, and once again, I would get the answer of 384 milliliters of water. So of these methods, I typically use the second one, the subtraction idea, because some problems I'm not actually solving for one part in the first step. So I might know that 3 parts work together for a certain amount. When we think about how this problem might show up on a quiz or test, there definitely are parts to total problems. So one of the things I want to do is to be able to recognize them. So the way that I recognize this one is that this first sentence gave me parts and parts. So it's not giving me the total amount. And then when I'm asked the question, that additional piece of information was the total. And so I had parts and totals and nothing matched. My strategy is to create this bar model, which allowed me to create a total. And once I had created that total, I was able to set that up in the proportion. I'm giving you a huge hint on the test, and that is I'm asking you to create a bar model, which I'm hoping in your brain will trigger that you're working with a parts and total proportion. Now, when you're working with homework, I didn't ask you to create a bar model, so you want to be looking for clues that you have parts and a total, and then you can create the bar model and practice recognizing the type of problem and then implementing a strategy to solve.